In problem 15, this is a linear regression problem. It says we want to use the demand as our explanatory variable to predict the response variable price diff. So our explanatory variable is always down at the bottom. Our response variable, or y, would be on the side here. So first, what is the least squares line or the linear regression equation? So this we just read straight off the chart. So here's where it gives me my equation here. So we have y equals 0.297x minus 2.276. In math, we usually write the part with the x first. In statistics, we usually write the number that's by itself first. So I'd probably rewrite this as y equals negative 2.276 plus 0.297x. Now, if you don't rearrange that, that's fine. Just make sure on a multiple choice exam that you can tell that those two equations are the same. Now, I like to go one step further and instead of x, put demand, and instead of y, put price diff. That way it just makes more sense to someone that doesn't like math as much. So my price difference is going to be equal to this negative 2.276 plus 0.297 times demand. Now, what is B0? What is our intercept and interpret it? Does it have a practical interpretation? So for that, the B0 is the notation that we use for our intercept, which is the number that's always by itself. So B0 is equal to negative 2.276. What does this mean? Okay, the intercept is always telling us, well, if x is 0, what is y? So if x equals 0, what is y? So in our case, x is our demand function. So if demand is 0, then the price difference will be negative 2.276. Now we're supposed to say whether or not this would be practical, and I imagine it would be practical enough because if your demand is 0, if no one really wants your object, then your price difference would have to be negative. You would have to drop your prices if no one's interested in your product. However, if your demand dropped all the way to 0, I imagine you're not selling your product at all, so it probably doesn't matter. But in this case, maybe practical. It's not, obviously not practical like some problems. What is B1? B1 stands for your slope, which is always the number attached to the x, so 0.297. And this says if x goes up 1, y goes up 0.297. So if demand goes up by 1, we expect the price difference to go up by 0.297. Now let's predict the price difference when the demand is 11. So we just plug x equals 11 into our equation. So y equals negative 2.276 plus 0.297 times 11, which gives me 0.991. So if our demand is 11, we expect the price difference to be about 0.991. Now, are we worried about extrapolation? Well, if you look here on our axis, we start with data about 7, we go to data of almost about 10, 11 would be right here. It's not really far. I could probably guess we might continue that same pattern up to 11. So it is slightly off the charts, but not so much that I'm really worried about extrapolation. What about, though, when demand is 60? Here's x equals 60. So y is going to be negative 2.276 plus 0.297 times 60, which is 15.544. But note that 60 is going to be somewhere way, way off the charts. I have no idea if that relationship keeps going up in that straight line by the time I get way off to x equals 60, and I'm probably not going to trust that at all. So I would make a note that this is extrapolation, and I probably won't trust it. So this is extrapolation, and I probably won't trust it, just because x equals 60 is so far from all of the rest of our data values.